Hello, my name is Doug Rose. I'm a seasonal resident of Nantucket, not affiliated with any of the stakeholders in the Sconset Bluff Geotube project. I'm not a scientist, but as an interested layperson, I appreciate this opportunity to submit for the consideration of the Nantucket Conservation Commission challenges to two findings from the 2021 annual review of the Sconset Geotube project, prepared by Epsilon Associates. I'll be reading from notes so as to stay on track, and if I do this right, it should take me about 12 minutes to get through. My comments focus on two definitive statements that Epsilon has repeatedly made in their past annual reviews. One, quote, there is no indication of accelerated beach erosion in excess of historical observations in front of or adjacent to the geotubes. And two, there's no indication of adverse effects to adjacent beaches. The first claim is the most hotly contested of this long-running dispute and can be framed as a simple question. Is there or is there not evidence of accelerated beach erosion at adjacent beaches since the installation of the geotubes? Let's keep things simple by focusing on what is called the project area, which runs from Transect 94, just north of Sankaty Light, down to Transect 88, near where Ann's Lane intersects with Baxter Road in the south. The geotubes are at transects 91 and 91.5, which you can see highlighted in the orange in the map on the left. Next, we need to choose two time periods, a before and after. September 2013 serves as a logical midpoint for an analysis like this because it was the last survey conducted prior to the installation of the geotubes in January of 2014. In order to minimize seasonality as a variable, let's stick with September surveys for this analysis. September 1998 was the first survey conducted in the month of September. September 2020 is the most recent survey conducted in that month. Here's what the erosion rates look like for each of those 15 locations. These numbers represent average annual movement of the mean low water mark in the 15 years before the geotubes were installed versus the first 7 years after. I have a hard time discerning much from a black and white chart like this. So here's what those numbers look like in sort of a heat map, where hot red symbolizes higher rates of erosion relative to other locations. It's pretty clear that the pattern on the left differs from that on the right. Sure enough, before the geotubes were installed, the areas to the north were experiencing fairly modest levels of annual erosion relative to what was happening to the south. As we can see, that trend has reversed since the geotubes were installed, with higher rates of erosion to the north, while erosion has moderated to the south. It's noteworthy that these are not isolated observations. In 6 of the 7 measurement locations to the north, the erosion rate has accelerated quite significantly. So the finding from this analysis is clear. Since the geotubes were installed, the annual shoreline erosion rate at and to the immediate north of the project has more than doubled, an increase of 117%. To double check these results, I did the same analysis using dozens of other timing scenarios, and in all of those alternatives, the findings are consistent with this one. The geotubes appear to be at an inflection point of shoreline erosion patterns. It's helpful to put this change into historical context. Here's that same bit of data from the last 22 years that we reviewed on the previous slide, just kind of scrunched up a bit to the right. So we can compare it to historical data from the previous 150 years. Thanks to Gordon Thompson at Baird for this information. It's interesting how up until 2013, the greatest variability in terms of either erosion or accretion tended to be to the south. Shoreline change was relatively moderate to the north. That pattern has changed since the geotubes were installed. So why is it that Epsilon's findings are so contradictory to these? I believe it all comes down to a difference in methodology. To illustrate how differing methodologies can yield very different findings, this chart shows how the shoreline position has moved over time at transect 91.5, near the north end of the geotubes. The y-axis shows the mean low water mark at various points in time. Downward movement represents erosion. Upward movement represents accretion. The x-axis tracks the 27 years from November 1994 through March of 2022. In calculating coastal erosion rates, the favored statistical method is called linear regression. It's favored for good reason. It is less susceptible than some calculation methods to the influence of errors and aberrations because it gives weight to every data point in a series to determine what is referred to as the line of best fit. That's that dotted line right there. This is the method employed by Epsilon in its analysis. Using this method, and using every data point from November 94 through March of this year, we find that the rate of erosion at this location has declined from 4.2 feet per year to 3.3 feet per year, or a deceleration of 21%. By contrast, endpoint rate uses only 2 points to determine a slope, subtracting the shoreline position of the start point in 1998 here from that of the endpoint in 2013, and dividing by the years elapsed. Using this simple, some might call it simplistic method, the rate of erosion has jumped from 2.2 feet per year to 5.3 feet per year, or an acceleration of 141%. This is the method used in the heat charts I showed you earlier. So what does the research say about which methodology is best? A study published in the Journal of Coastal Research states that while linear regression is, quote, more representative of trends over long time periods, the exception is when short-term changes can be documented as a real change, meaning, for example, not a measurement error. Further, it states that a recent trend may reflect an important change regardless of the statistical implication. So the research says that linear regression has its limits. Specifically, it can mute the effects of a major event late in a study period. And of course, this is precisely what took place at Sconset Bluff in the storm season of early 2013. The shoreline here advanced seaward by 40 feet, not as a result of an aberration or a measurement error, but by the bluff collapse of March 2013. In geological terms, bluff collapses are an inevitable part of any natural coastal bank system. But linear regression gives this change no greater weight than any of the 45 other data points to be balanced in the pre-geotube line of best fit that we see here. As you can see, the linear regression line muffles the impact of this very real event, and so renders a relatively steep erosion rate before the geotubes. This in turn produces a somewhat, dare I say, flattering comparison to the erosion rate after the geotubes were installed. It's revealing to play out the differences between methodologies across multiple locations. On the left of this slide are the two measurement locations immediately south of the geotubes. In the center are the two directly in front of the geotubes, and on the right-hand side are the two immediately to the north or downdrift of the geotubes. The dotted lines on these slides represent the erosion rates derived using linear regression. The solid purple and orange lines here represent endpoint rate. And immediately to the south of the geotubes, the two methodologies actually produce quite consistent findings. Using either linear regression or endpoint rate, we see that erosion has decelerated to the south. Where we see real differences between the methodologies is at and immediately downdrift of the geotubes. While linear regression shows relatively steep erosion rates in the before period and moderate rates in the after period, endpoint rate reveals the opposite. A long-term erosion rate significantly moderated by natural accretion late in the before period, followed by significantly accelerated erosion in the after period. The introduction of a new variable, a man-made structure specifically designed to prevent bluff collapses in the future, i.e. geotubes, makes it important to fully account for the impact from the last bluff collapse in calculating shoreline erosion rates in the before period. What all this means is that the methodology used to support Epsilon's very definitive statement that there's no indication of accelerated beach erosion is not definitive. Now for the second question, is there or is there not evidence of adverse effects to adjacent beaches? The answer to this question is quick and I believe pretty much beyond debate. The beach has narrowed significantly in front of the geotubes. Once again, using Transect 91.5 at the northern segment of the geotubes, we see unmistakable signs of a narrower, steeper beach. As just one point of reference, these two photos are from the town of Nantucket's GIS mapping system. The top one is just prior to the geotube installation. The second is recent from 2021. It's important to note that photos like these represent isolated moments in time. These could have been taken at high tide or low tide, winter or summer, and so are an imperfect gauge of change over time. The profiles from Woods Hole Group that I'm about to show you provide a much more accurate way to visualize change. This chart shows a cross-section or elevation view of the beach, with the toe of the bluff to the left and the nearshore ocean floor off to the right. It helps to imagine that you're standing on Sconset Beach looking north. In September of 2013, just before the geotubes were installed, you can see a fairly expansive beach here, roughly 115 feet wide at high tide. And here's that same beach 7 years later. Two things have happened, and neither are subject to debate. The first is that with the installation of the geotubes, the toe of the bluff was moved artificially seaward about 30 feet, and they've held it there ever since. I don't think anybody is disputing that fact. Secondly, in the 7 years since then, you see a significant retreat of the shoreline to the tune of another 30 plus feet. The net effect of this is that the walkable beach here has narrowed by more than half since the geotubes were installed. And to the degree that we continue to see shoreline retreat, we will continue to see diminishment of the walkable beach here. In an environment as dynamic as the Sconset coastline, a categorical statement like, quote, no indication of adverse effects sets an extremely high bar, and based on the findings shown here, is overstated. I worry that absolute language like this resembles a PR soundbite or a legal stance, more so than an impartial scientific assessment, and should raise some healthy skepticism among objective observers. To recap, whereas Epsilon insists that there is no indication of accelerated beach erosion in excess of historical observations in front of or adjacent to the geotubes, as shown here, there is clear evidence to the contrary. The erosion has indeed accelerated, that it is indeed a departure from historical patterns, and that it is strongly correlated to the presence of the geotubes in terms of both timing and location. Acknowledging that correlation doesn't prove causation and that many natural forces are at work in Sconset's dynamic littoral system, if I had the opportunity to ask the good folks at Epsilon directly, I would ask them to address this finding. It would be especially enlightening to get their perspective on the methodology question, specifically in the context of a coastal bank environment. And while Epsilon continues to argue that there is, quote, no indication of adverse effects to adjacent beaches, setting aside for a moment the ample evidence of accelerated beach erosion, it is an empirical fact that the beach in front of the geotubes has narrowed significantly since the project was installed. This is at least partially attributable to the introduction of an immovable man-made object on the landward side of the beach, specifically designed to prevent movement of the toe of the bluff. I suppose this poses a subjective question about the definition of terms like adverse effects. In this observer's opinion, a beach that is being narrowed significantly by human actions absolutely constitutes adverse effects. With that, I'll end by thanking you for your time and for your service to the Nantucket community. I welcome any comments, questions, or feedback that could help clarify any of these observations. My contact information is provided here. Thanks again.